Event-driven programming. There are three main types of style programming can fall under: procedural, functional, and object-oriented. These paradigms, and more specifically, programming paradigms, differ in their approach to software construction. Each of the three types of programming has a different methodology of how to create a program. Procedural programming revolves around a methodology that uses calls to procedures, where the procedure executes and then outputs a result. Procedural programming takes a top-down approach to programming, where a series of statements or instructions are written and then executed from the top of the program down to the bottom. Functional programming strictly uses functions, or as we've sometimes referred to them, procedures. In this paradigm, a function calls another function, which then calls another function. All of the functions that exist in functional programming code are considered its data. It means that they can be used as parameters, return values, or can be used to build other functions. Object-oriented programming uses the abstract concept of objects to hold attributes and behaviors of the object. Object-oriented programming encapsulates these attributes and behaviors that direct the functions of the objects. The behaviors and attributes are written into the classes that the objects reference. Encapsulation within object-oriented programming protects the original code of a class from being changed without permission, but allows for customization of a class's objects. Event-driven programming is a programming structure that is designed around the events that begin or continue the execution of a program. Event-driven programming looks for user actions, such as key presses, mouse clicks, or incoming messages, to initiate a program. Event-driven programming can be considered an asynchronous programming design, as the program consistently runs as it looks for and executes code based off of events occurring at varying times. The following examples could be events that could initiate a program: when the mouse is clicked, when the W key is pressed, when a star icon is pressed, when an up key is pressed. Event-driven programming has many links to the object-oriented programming paradigm. Much of the software that's used to create event-driven programs supply pieces or blocks of code, and the user chooses to define the action or event that should be included. Where we see ties to object-oriented programming is in the encapsulation of data in classes. This allows objects to hold information about their attributes, behaviors, and events that control what occurs with the object. Most object-oriented programming languages support event-driven programming. As we continue our discussion on event-driven programs, we'll use a generic pseudocode to convey how it works. We'll use a blue triangle within a grid of cells to represent the output to our event-driven programs. Our triangle will always begin in the bottom left cell. Events begin and drive the execution of statements within an event-driven program. For example, when the mouse clicks, move 5 pixels. So you can see the blue triangle has moved 5 pixels to the right. First, the mouse click occurs. Then the triangle moves 5 cells in its default directional movement, which is to the right. Event-driven programs provide an outline of code, as we've mentioned, which comes with default settings or attributes. This means that with generic statements, actions will occur according to the default code. Event-driven programs, though, can get more specific. We've now included a counterclockwise turn in our program. The mouse click begins the program, and the triangle executes each statement. So it moved 5 pixels to the right, then it turned left 90 degrees, then it moved 5 pixels in that direction, which was up. In this program, we look for a mouse click to begin the program, but once we begin, the program must determine the color of the triangle in order to continue executing code. So when the mouse is clicked, it checks to see the color of the triangle. If the triangle is blue, change it to red and then move 5 pixels. Well, what would occur if we changed the code inside of the if condition? Now it says if triangle is red. That's right, our triangle would not move. Since the attributes of the triangle do not match what the condition is looking for, the execution of the code ends there. So since the triangle is blue, the code inside of that if statement will not run. The concept of concurrency occurs often within event-driven programming. This means that while the program is running, it is constantly waiting for additional events to occur and execute. Multiple events and their code could then occur while the program is running, but at different times. So here we have a program that's constantly waiting for up or down to be pressed. So here, the event that begins the program execution is when the star button is pressed, and here, a key press event that if it occurs, this code must be executed, and here is another key press event, down, where if this button is pressed, this code must be executed. This program allows events such as the pressing of the up and down keys to occur at any time, and then their code executes. These are asynchronous events. Since the events can occur at any time, the program does not follow the pattern of executing statements from the top down. When using asynchronous events in a program, it can create some latency issues when executing the code. This may result in the user experiencing a delay in their output as their program attempts to run many events at the same time. Before including asynchronous events in your code, be sure that they are necessary to the functional outcome of your program. When programming, whether it is working within an event-driven paradigm or any other paradigm, it is an essential goal to create the highest quality code possible. High-quality code considers a few factors. The code is as efficient as possible and includes only necessary lines of code to conserve memory and processing power. The code is accessible and inclusive of all users, and the code successfully fulfills its intended function. Code accessibility encompasses a few points. Is the program accessible on multiple devices or programs? Is the program and its execution available to all users? Is the program well documented so that any programmers could understand the intent and logic? Creating a program that is available to screen readers and can be communicated through text-to-speech applications makes it available to users who have visual or auditory impediments. Enabling a program to be both accessible on desktop and mobile devices expands access to the work. Finally, a well-documented program ensures the greatest understanding of the source code to anyone who could offer feedback and suggestions. High-quality code can be achieved through rounds of feedback offered from many sources. Code reviews or peer feedback is the process of repeatedly meeting with colleagues to systematically review source code to ensure that it functions as well as possible. User feedback is received after releasing software to the public, where users can offer suggestions on functionality, accessibility, or interface. This data from online visitors is often received during beta testing, but sometimes after an official release of the software. Feedback and suggestions from either code reviews or user feedback can aid in achieving high-quality code.